Hi all, my name is Rahul, and this is my first lecture on YouTube. So please be gentle. And it's entitled, If You Look at the World Differently, You Break the Existing Paradigm. And to frame this a bit, I'm going to draw back an old paradigm of bloodletting. So a few hundred years ago, the paradigm was that if you were ill, the belief was that you had bad blood. And as a result, you would have to go to the doctor, who was usually a very, very well-trained university professor or doctor, and he would then make an incision in your vein, your wrist, on your vein somewhere, and then extract the bad blood. Now, had this been correct, maybe we would have also had smart industrialists and Germans and the British and the French all defining sort of tools to extract the bad blood. So we would have vacuum pressure, bad blood extractors, and fat nozzled bad blood extractors, and all things that would be required to extract the bad blood faster. But the paradigm was wrong in the first place. So all that investment in that technology would be essentially a wasted effort. So it's very, very important to first challenge the paradigm, understand if the paradigm is correct in the first place before moving on forward. Now, in this lecture, I want you to be as interactive as possible. So pause the video, think about the questions, try to do it firsthand first before watching the answer come to you. And so here I ask, what do you see? What do you see? And you probably say, it looks like a sun radiating outwards. Yeah, it's probably true. And so, yes, these straight lines you see. What else do you see? Do you see that? The circular lines? And do you see maybe the combination of both? Very good. Now, this picture, when I saw it, it was like, I've seen this before. And when you look at a very old book, this was a very old book called Elementary Lectures on Electric Discharges, Waves, and Impulses. And this, the chapter that was discussed is called the electric field. And here, Professor Charles Proteus Steinmetz, he is essentially a god of electrical engineering. He took Tesla's AC motor and perfected it. But in that whole perfection of the motor, when he writes his lectures, he's hypercritical of the concept of the electron. So and he actually says that the how does he phrase it? It's sort of like the antiquated, outdated concept of the electrostatic charge on the conductor destroys the analogy of how electricity really works. And it's really a dance of the fields. It's an interaction of fields. It's got nothing to do with particles. In fact, um, yeah, he was very, very critical of this fact. And secondly, it reminded me of a stereolithographic projection of a sphere. So let's cover these two and then we'll get to a point. So this is the picture that Professor Steinmetz puts together in his 1917 book. And what you see is two things. This is the electric field of a conductor. And so in here in the center is it's a piece of copper wire. So it's a cross section of the copper wire. And he says, if you consider that copper wire, you'll see two effects. One is a circular set of lines, which is called the magnetic field, and a sort of a radiating outwards set of lines called the dielectric lines, the dotted lines here. Okay, and together these two play together and interact and form what's called the electric field of the conductor. Okay, so this essentially in our little sun model here is also then the electric field of the conductor. Okay, one more thing then Professor Steinmetz does is he amps it up a bit. He says, well, if you put two copper wires of electricity and you amp it up even more, you're going to get this field where the dielectric lines connect and the actual magnetic fields line push away from each other. And this then was the second conclusion that Professor Steinmetz put together. Now, when I saw this, it immediately triggered a thought, which was that this is actually a stereolithographic projection of a sphere. So once you have this picture and that picture, you can then reverse engineer and backward project what the field geometry of the 3D shape looks like. So what he's saying is this is the three-dimensional field, electric field of a system. That's what it looks like. Now, when I saw that and I saw these straight lines and these rings around it, it for me just didn't sit well, and we'll get to that. So uh, I know I'm already challenging the great Charles Proteus Steinmetz, but I have incredible respect for him. But yes, I am challenging him as well. So let's move on, though. So Professor Steinmetz's statements were next generation when I saw it for the first time. And compared to what we're being taught today, 100 years later, here we have the smart Professor Dave and the very smart Professor Matt Anderson and the very smart Derek from Veritasium and the very smart institution of Massachusetts Institute of Technology, all speaking the same nonsense, which is a very simple set of lines that go one direction. Nature never works in one direction. So to 100% improve this view, you need to have a equal and opposite. So, but that wasn't the point I want to bring across. It was a stark comparison to this picture. So Professor Steinmetz says there are two fields playing together, and those two fields playing together create the electric field, and not this single field with no context and no nothing. So let's move on. What else do you see? So do you see that? This is just a simple Fibonacci spiral. Do you see that? And what about this? And what happens if we combine these? We get to something like this. This is more a Willy Wonka world of bundled fields. And so this fundamentally changes the paradigm. Now, if the insipid pictures of Professor Dave and Matt Anderson and Derek from Veritasium regarding the magnetic field is version 1.0 of our understanding, then Professor Steinmetz one was a version 2.0. But could there be a 3.0? Remember, everything that all our technology that we have sits on the current progress of the AC motor, the current electricity system of our existence. And what if it was just half knowledge that we have? Yes, it works. I give it, granted, it works. But if there's an electricity 3.0, it requires a fundamentally different understanding of how the magnetic field works, how the electric field works, and how the dielectric field works. Okay? So assuming this is this Willy Wonka view of the fields, Rahul's Willy Wonka view of the fields looks, let's backward project this now. So you still get the radiating lines, yeah, but you realize that these lines are simply an illusion. They give an appearance of straight lines, but they don't exist. What is really happening is you have two fields that are crisscrossing, and at the intersection point, they create almost like, oh, I don't know if it's a photon or whatever, but whatever it is that creates that point, which creates the illusion of light or electricity, but it gives an illusion of a straight line. So maybe one basic conclusion, perhaps light doesn't travel in a straight line. This old Euclidean, probably it's almost stated with so much of how can I say, so much of gravitas. Maybe that's not right. Yes, I know about the whole Einstein uh, talking about, high gravitational areas causing light to bend. Talking about that. Imagine in neutral space. What I'm saying is that these two fields, when they cross, They give an illusion of straightness. So now, going back to what you need to do as homework, this is the story. Assuming that this stereolithographic projection, this big picture here, creates that and creates that. I want to know from you, challenge your mind now. What would this Willy Wonka view, this Willy Wonka field line view, result in when you backward engineer the stereolithographic? So I want to know, what does this panel look like? This sort of Y axis field. And then what does the combined picture look like? So please email me, kaushiprat@gmail.com. I look forward to seeing your ideas and input. Thank you.